test systems are not necessarily easy to put together unless you have the right base. So, Jason, could you tell us a little bit about your new technology?
Yes, so we at Tesseract, we make something called TestPoint that is a automated test framework. So we basically took all the stuff that engineers would need to do when they're creating a test system initially and basically did it for them to try to make it easier, try to take out all those tedious things and just so that they can focus on the tests and worry about the thing that they're trying to test versus all of the details of hardware communication and having things interact with each other and all that stuff. We try to take care of all of that for them.
Now, am I programming this in something like C, or can I use things like MATLAB or LabVIEW, for example, that I might have been using to configure our system to test them initially?
You can use it in a lot of different things. Right now, the back end of our whole system is actually programmed in LabVIEW, but you can still reference the hardware abstraction layer or other things that are programmed in LabVIEW in other languages. In a similar way that LabVIEW can reference all those other languages, so the primary basis for everything we're doing is LabVIEW, and the primary test executive that we're using is TestStand.
So if I have some virtual instruments, for example, I can incorporate into this process.
Yes. So if you already have existing code, say VIs or virtual instruments in LabVIEW, it's something relatively easy to incorporate in there. We also have this part of our framework also includes like an HMI type of system called Task, which stands for Tesseract Automated Solutions Controller, but it's basically just the place where you put all of your UIs. It's a single location so that both developers and operators can go in and do the things that they need to do. You can debug, you can do all these things in this one location. So that makes everything a lot easier to kind of, instead of trying to keep track of all these different UIs all over the place, we have one single place that you can just go and do that. This is a view of Task, and this is basically the HMI or the user interface that either the operators or the developers would use. And this is the operator view. And so this is pretty simple. Right now I'm just going to click on this test, and right now we're doing testing flashlights. And so right now I have this little interface that comes up and I can choose which flashlight to test. And right now I've got that black flashlight on there, so I'm going to go ahead and run that test. What it'll do is it'll turn it on, test it at different voltages. It's really simple. And then give me a pass or fail. So right now this one passed. And I can see all the different things. I can see a report of what happened, what passed, what failed, what limits we were testing at, and all of that. Now, so this is the operator view. So what's going on behind the scenes to make this actually happen? So once we've seen what it's like in the operator mode, we can go look and see what's going on behind the scenes. And for that, we have an admin mode, or for the developer, to go and look and see what is actually happening. And what we have over here is we have an analog discovery device, which is a basic data acquisition device with analog inputs and outputs. We have a flashlight that is getting voltage from this, and we also have a photometer that is being read by this. We have set up in our hardware abstraction layer for the software to think that this is a power supply, just a generic power supply. We also have set up in another place in our hardware abstraction layer to think that this is also a photometer that is reading light measurements. And inside the software, we can go in and test that. So I can go in and look in my power supply UI, which I have all in this single location for UIs called Task, and I can click on DC power supply. And within here, I can go and I can change my voltage and test things out. I can turn it on. I can go and make sure everything's working in there. I can turn it back on and then go look at the same thing on the photometer, tell it what photometer I'm using, and then get a measurement, see what that looks like. Okay, that looks good. Now, if I'm an engineer and I'm wanting to automate this, one of the things that is nice that our hardware abstraction layer and Task comes with is something called record and playback. I can do a new recording and I can go and say here, I'm going to record this, and I click start. I can go in and I'm going to turn it off. I'm going to set my voltage to something else. I'm going to go into my photometer, take a measurement, Go back into the power supply, set the voltage to say something a little bit different. Go back into the photometer, take another measurement, and we'll go into the power supply and we'll turn it off. Okay, so now we go look and record and play back, and here's all the things that we just did. So we're partway there to being able to animate or to automate this. So right now I'm going to highlight all of these, and I'm going to go in because I see some wait times that was basically the amount of time it took me to do each of these steps. But I don't want that. I want to turn that to 0, so I can change all the wait times to 0. I can also go in and I can delete stuff that I don't really need. There's a couple things I'm in here that I don't really need to do every time, so I can just go and remove those. Now I can play this back. I can just play it back and see what happens there, and I can export that. But if I'm fine with that, I can do that. But most of the time, I need to do something better than just run it in here. So in this record and playback, I have the option to export, and I can export as a CSV, which would let me go and implement this in another test executive, or I could just export it directly to NI test stand. If someone's using NI test stand, you can just do a direct export from there, and then just run. Then you have your automation about halfway done. It's already in there. So the other advantages, the other cool things that we have inside of Task are things like the ability to go in and check. So when you create a HAL model, when you add a model to the hardware abstraction layer, in this case I added a power supply, I can go in here and I can check each of the functions or each of the methods that I used in that power supply, make sure that it works. So it's a great way to test out your model when you make it in the HAL. Now, once I've made that in the HAL, and I have another, let's say something like this, let's say this little device breaks and I need to use a different one. Well, I've got other devices that I can plug into that, and instead of having to go through and change all the code, all I need to do is go into a configuration utility, and this is the configuration utility that we have called our configuration editor. And because I already have another device that I have available in the HAL, I could just go in here, say, well, I now want to use this other different device that has completely different drivers, and then if I had it connected up, all I would have to do is go back and I can run this same exact program using the exact same software, and it all just talks to different hardware. It all just works. That's the advantage of having a hardware abstraction layer. Whether you use the Tesseract one or something else, that is a great advantage, because it turns out that in real engineering stuff, this happens all the time, where you need to swap out some instrument or do whatever. So that's generally what the test point from Tesseract does in a nutshell.
Well, great. Thanks for filling us in on your test platform.
You're welcome, and if anybody has any questions, they can go visit Tesseract.com.